Welcome to an impromptu part 2 for today's problems. There was an error and I caught it when I was recording the last video, and instead of just throwing away the 9 minutes I already did, I just decided to make a part 2. Alright, so in your body and other organisms as well, we can produce modifications of our sugars. So some bacteria will produce what are called thiol sugars. Thiol sugar is, instead of an OH, you can have an S there, sulfur. Sulfur means thiol. So if we look at 2-deoxy 2-thiol beta D glucose, what does that look like? So first we have beta D glucose, which I have drawn here. If we look at beta, the OH is pointing up. The CH2OH is pointing up, so that's beta. And then the 2 position. So how to number carbons. If you have a 5-membered ring, your anomeric carbon, your former C double bond O carbon, is number 1. So it goes 1, 2, 3, 4, 5, 6. So it's 2-deoxy. So 1,2-deoxy means there's no oxygen. But it's 2-thiol, so we have an SH instead. So that's 2-thiol, 2-deoxy 2-thiol beta D glucose. And now phosphorylated sugars, beta D fructose 6-phosphate. So we have our fructose in the beta position, OH is pointing up. Our CH2 former OH is pointing up, so that's beta. The way to count a sugar that has 4 carbons in the ring is that the CH2OH connected to your anomeric carbon is carbon 1. So this is carbon 1, 2, 3, 4, 5, 6. So we want 6 phosphates. So we have a phosphate group instead of an OH. Right. The last thing we're going to talk about in this problem set are reducing sugars. So first, let's look at our disaccharides. A disaccharide is 2 sugars connected through a glycosidic bond. So this bond here that connects sugars is called a glycosidic bond. Now, to determine if something is a reducing sugar, you first have to find the anomeric carbon on each sugar. So here we have a carbon that's connected to one oxygen and another oxygen, anomeric. Carbon connected to an oxygen and another oxygen, anomeric. If both of your anomeric carbons are in a glycosidic bond, like we have in A, this is a non-reducing sugar. Let's go to B. So here we have anomeric carbon. Here we have our anomeric carbon. So this carbon has oxygen, oxygen. This carbon, oxygen, oxygen. You see our other anomeric carbon is not in a glycosidic bond. This is called a reducing sugar. So since this anomeric carbon is free, it could become linear again. It could reopen up. So that is a reducing sugar. So C, anomeric carbon, anomeric carbon, they're both in a glycosidic bond. This is a non-reducing sugar. D, anomeric carbon, not in a glycosidic bond, so it's reducing. So by definition, any monosaccharide would be a reducing sugar because it has to have a free anomeric carbon. Alright, so that ends our impromptu part 2. If you were confused with anything or you want to talk things out, please don't hesitate to email me. We can talk by text through there, or if you want to do a video conference, I'm more than happy to do that. Otherwise, I hope to see you sometime again in 2020, and see you in the next video.